All right, welcome to the homework help session. We've got Ren Johnson here, and the first question that she's brought us this morning is one on long division of polynomials, not long division of numbers. We'd be in big trouble if y'all were asking me questions about long division with just numbers. But I do want to step back for a moment and talk about long division with just numbers, because it will give us a little bit of insight as to how we're going to write the quotient that we get after we do the division. Now, I've already set up the blanks like you'd see on my math lab to put your answer in. So it wants the quotient given in the form of quotient polynomial plus remainder over divisor. So let me just do a quick long division problem here. Let's say 3 into, I don't know, 28. Well, 3 goes into 28 9 times. 9 times 3 is 27. I'm going to subtract those down, and I have a remainder of 1. Now, I could choose to write 1 like you used to, remainder 1 when you were in like 2nd grade, or I can write remainder over divisor as being my quotient. So remainder over divisor. 9 1/3 is the same thing as 9 plus 1/3. So what this means is if I go back and literally multiply these two things together, I will get 28. So it's not fun to multiply or do any sort of operations with fractions when you're dealing with mixed numbers. At least I would prefer to have it just as fractions when I'm doing fractional math. So this is the same thing as 3 over 1 times, I'm going to turn this back into a mixed number. That's 28/3 because 3 times 9 is 27 plus 1. So 28/3. When you multiply fractions, you multiply straight across, and I'm keeping them separate for a reason, because I can come back and divide my 3's out, and you can see I get my dividend that I started out with. Or I could have written this as 28 is the same thing as 3 times 9 plus my remainder on the outside of that product, which is 27 plus 1, or 28. So let me get a different color. What my math lab is asking for is for you to write your quotient in this form here. Because like I said just a moment ago, 9 1/3 is the same thing as 9 plus my remainder over my divisor. Does that make sense, Ren?
Yes, and that's also how you can check your work, right, to see if you have the right answer?
Yeah, this is me checking my work right there, going back and multiplying it together. Multiplication and division are inverse operations. So one undoes the other. So if you've done division, to check it, you're going to go back and multiply.
Okay.
Okay, so I'm going to erase all that off the bottom of the screen so we have plenty of room to work with long division of these polynomials here. Okay, so one of the most important things with long division of polynomials, or even synthetic division of polynomials, is you have to check the polynomials that you are dividing and dividing by, and make sure that it's in standard form and that no term is skipped over. So say that 2x didn't exist there in that first polynomial right here. Say it was just 6x cubed minus 4x squared minus 36, and I had no x term. I would need to put a placeholder in of a 0 term. It would look like this, if this were the case. Plus 0 x's minus 36, I've got to have that placeholder. So in this case, you don't need a placeholder because you haven't skipped over, in a sense, any term spots or place values of terms. I know that I'm like mixing mathematical concepts, and that's not really what you call it. It's not place value, but it would be the same as place value if we were just dealing with numbers. For example, you would never write 102. Oops, hang on. You would never write 102 as 12. You have to have that 0 to hold that place there. Same idea with putting in a 0 placeholder for a term that's skipped over in standard form. So is that clear so far?
Yes, so far.
Okay. All right, let's go ahead and actually do what you came to see happen.
No.
So this is 2x minus 4. That is our divisor. And we are dividing our dividend, which is 6x cubed minus 4x squared plus 2x minus 36. Okay, so I've set it up just like a regular division problem here. Now the first step with long division is to estimate. And when you estimate, just like with regular long division, it's estimating how many times that number will go into the other. You're going to estimate, but you're going to focus on what I call first terms. So here's what I'm talking about with first terms. I'm going to focus on the 2x and the 6x cubed. So my question with estimation is, what can I multiply 2x by to make 6x cubed?
Would it be 3x?
It would actually be 3x squared because you need one more x in there. So
you add.
Exactly. When you're multiplying like bases, you add the exponents. Very good. Now, here's the kicker. It needs to go in the x squared column. Just like you keep your place value lined up with regular division, this 3x squared needs to live in its appropriate column. And your second step with long division is the same as regular division. You're going to multiply down.
Okay.
So this is the multiply down. I'm going to multiply. It's basically distribution of the term at the top to each of the terms in your divisor there. And what I get when I multiply down is 3x squared times 2x is 6x cubed. 3x squared times negative 4 is negative 12x squared. Now, the next step is to subtract. But when we're dealing with polynomials, we never subtract. We combine with the opposite polynomial. So let me show you what's going on, and then I'll show you what I normally see students do. What I'm really doing is subtracting this entire polynomial. Now there's a negative 1 there that gets distributed to both of those terms. So what we usually do is just change the signs of our new polynomial there. So this becomes, and then I combine with that opposite that I've created, negative 6x cubed positive 12x squared.
So that's why the signs change. I never done that before.
Yeah.
It's visible.
Yep, subtraction of that polynomial and that negative 1 gets distributed to those terms. So,
okay.
And this is what happens when you do this every time, because of the way you've chosen your 3x squared up there. These first terms are always going to be opposites and drop off. That's what you want happening. You're trying to whittle this thing down bit by bit. And then when I combine my negative 4x squared and my positive 12x squared, I end up with 8x squared. Good so far?
Yes.
Okay, very good. Your fourth step, and this will be a blast from the past, bring down. So we literally bring that next term down, and then the fifth step is to start all the way back over at the top as many times as you need to until you end up with no more terms to bring down and divide into. So I'm back up to estimating using first terms.
Okay.
Now I'm looking at 2x and 8x squared. So what do I need to multiply 2x by to get 8x squared?
Just 4x.
So you want to make sure you put your sign. It is positive 4x. And I'm ready to do my second step of multiplying down. So this goes to both. And I get
-4 by, is it -4 times 8 or 2? This is where I get confused.
Okay, so I have 4x times 2x, which is 8x squared, and then I have 4x times -4, which is -16x.
Okay.
Then I come back and change my signs. You good?
Yes.
Okay. So my first terms are opposites, which is what I want happening. I'm whittling it down. Now I'm going to combine 2x and 16x to get 18x. And I have another term to bring down. I have a -36. I'm back to my first step of focusing on first terms.
So that would be 9.
Positive 9. Multiply back down, so 9 times 2x is
18x.
correct, and 9 times -4,
-36.
-36. And I'm going to change my signs. And actually, both of those terms go away. I have a 0 remainder, which means that both your, let me get a different color and a thicker pen to show you this. Since I have a remainder of 0, that means that 2x minus 4, the polynomial, and 3x squared plus 4x plus 9 multiply together to give you your divisor, 6x cubed minus, I'm sorry, your dividend, 6x cubed minus 4x squared plus 2x minus 36. No remainder. So what your question is asking you to do is give the quotient. So like if I were doing regular division with numbers, 2 divided by 6 is 3, there's no remainder there. So my quotient would be 3. So my quotient here is 3x squared plus 4x plus 9. Oops, my pen went crazy on me. Hang on. Plus 9. And there is no remainder, 0 over 2x minus 4.
So you can put a 0 there.
And it's just making sure that you understand where that remainder would go, if there were one, what it means when there's no remainder. It means that these things are factors. So basically you've started factoring that polynomial. So if you were graphing this first polynomial, this would be your first step in finding the zeros of the polynomial or the x-intercepts. And then you whittled this down to a quadratic that you could either factor further, or you could just throw that thing into the quadratic formula and pull those x-intercepts out.
Just copying down your steps here.
You're fine. You're fine. Just guzzling down some coffee while you're doing that.
I'm so jealous. I need my morning coffee.
I'm a coffee snob. I mainline it in the morning, so.
Do you have a Keurig?
No, I actually have a percolator. I'm that much of a coffee snob. I only buy really, really good coffee because I drink it black. I don't put any sugar, no cream, no nothing in it. So I can tell the difference in a really good cup of coffee and a really bad cup of coffee.
Yeah, I believe it. All right, Ms. Gore.
Did you get it copied down?
Yes, I did.
Okay, did you have any questions about anything on the screen? Did something, I know it kind of looks jumbled up now that we've gotten to the end of it, but is there anything that you still have questions about with this process?
No, I really appreciate your different use of colors. That really helps out with the steps and everything.
Yeah, I've been doing that since I started teaching, and when I teach face-to-face classes, all my colleagues make fun of me because I carry around a huge marker bag, and I've got to have all my colors when I'm teaching, and I use it to highlight the work around the problem. So I appreciate you letting me know that it's helpful for you. I'll continue.
It's totally helpful. It really is.
Okay, let me clear our page and we'll go for your next problem here.
Okay.
All right.
I feel like synthetic division is going to be something that I'm going to really like once I understand it better, because it looks like it's simpler than the longer stuff. But I have a synthetic division problem for you. It's x to the 5th power. What was that?
Do you want me, I was about to say, I can use that last problem that we just did and show you the same problem with synthetic division. If you want me to. We'll use the one you have. I'm sorry, I'm just thinking out loud. Go ahead and let me know your problem with synthetic division.
Yeah, I'd totally be okay with that, but this one looks like it's done differently than the other one. That's the only reason I want to do this one. Maybe fine. I'm just overthinking it. It's x to the 5th power plus 1 over x plus 1. All right. And then equals the blank box plus x plus 1.
Okay. Okay, good to go?
Yes.
All right, so you have skipped over majorly many terms with your dividend there.
Yes.
So first of all, let me talk about C. And basically the setup for synthetic division is some value C, and then you have the coefficients of the dividend, the thing that's being divided. Okay? So that's your basic setup for it. This C comes from the factor x minus c equals 0. So one of those factors that you found when you we're factoring a linear factor basically. And if you notice, if you have x minus c equals 0 and you add c to both sides, you get x is c. So with my factor that I'm dividing by of x plus 1, that came from the zero product property x plus 1 equals 0. So I'd have to subtract 1. My x here is actually negative 1. I'm sorry, so this is my c value that I'm going to be dividing by. So you have to be aware that minus is in the form. So if you're dividing by an x plus 1, that really came from x minus negative 1, and your c is going to be negative 1. Is that okay?
Yes.
Okay, so I'm going to go ahead and set this up then. So my c is negative 1, and my coefficients of my dividends are 1 for x to the 5th. I have 0x to the 4th, 0x cubed, 0x squares, 0 x's, and a 1. Do you need to see that polynomial written out?
Why is that so? Because there's 5 x's?
Okay, yeah. So I start with an x to the 5th term that has an understood coefficient of 1. I have skipped over, let me write this in a different color. I have no x to the 4th. I have no x cubes. I have no x squares. I have no x's. And then I have my constant, which is 1.
Okay.
So just like on that last page when I said you never write 102 as 12, you've got to have that place value holder there. That's what you have to do with these polynomials that skip over terms like that. Does that make sense?
Yes, it does.
Okay. So this is probably, that step right there is probably why you were having issues. If you weren't putting the zeros in,
yeah,
it messes you all up because it's missing those placeholders for it. Okay, so let's go ahead and start with the synthetic division process, and I'll write your steps off to the side. Your first step is to combine down. So I literally just bring, there's nothing to combine with this one, so I literally just bring that first one down. Okay? My second step is to multiply with C. So here's my second step. I'm going to multiply -1 with 1. It's this one that I'm multiplying with.
Oh, yeah.
Okay? And your next step after you multiply is to write the result, or the product, I should say. Let me reword that. Another beauty of technology, being able to just quickly get rid of anything you didn't say correctly.
Yeah.
Write the product in next column. Okay, so -1 times 1 is 1. You okay?
Yes.
Okay. Your fourth step is the same as your fifth step in the last long division process, and that's to go back up to the first and start over until you run out.
Wait, hold on, Ms. Ford. Why is negative 1 times 1, 1? I thought it would be negative
Ooh,
1.
you're right, it's negative 1. Thank you. Because I haven't mainlined nearly enough coffee yet is the reason why. So
I was like, that's why it's so tricky.
So the last step I have written PRN, and if you're familiar with medical terminology, PRN means as needed. So you're just going to keep on going back up to the top of the list as many times as you need to until you get to the end. So I'm going to combine down, which 0 and negative 1 combined make negative 1. I'm going to multiply with C, so negative 1 times negative 1 is positive 1, and write my result in the next column. For real, positive 1. Okay, so I'm ready to start back over. Combine down. 0 and 1 make 1. Multiply with C. Negative 1 times 1 is negative 1. Combine down. Negative 1. Negative 1 times negative 1 is 1. Combine down. Negative 1 times negative 1 is negative 1. Combine down, and then you'll always want to draw around the last number a little box like that. The number that shows up at the very end in the little box is your remainder. So what does that tell you about the factor x plus 1? Remember, x plus 1 gave us a C of negative 1. What does that tell you about x plus 1? Since I have no remainder.
Yeah, so the 0 goes on top of the x plus 1.
Yeah, but what does that mean in regards to my original polynomial? What do you know about x plus 1? Just like when I divided 6 by 2 and got 3 with no remainder, I knew that 2 and 3 are both factors of 6 because I had no remainder. So 2 is a factor of 6, 3 is a factor of 6. We can agree on that, right?
Yeah.
Okay, so what you find out when you do this synthetic division process and end up with a 0 remainder, x plus 1 is a factor of x to the 5th plus 1.
Okay.
So also your quotient, what you're left over with, let me find the color I haven't used much on this screen. Your quotient is also a factor. Now let me explain how you get that quotient there, because that's what you've got to write up top, is your quotient. By the way, we can go ahead and put a 0 there for the remainder. So you started out with a polynomial raised to the 5th power, okay? You divided out one factor of x, which is going to take you down 1 in your degree, and you're left over with x to the 4th, x cubed, x squared, x, and 1. That is your quotient polynomial. So when you go to put your quotient into MyMathLab, it is x to the 4th minus x cubed plus x squared minus x plus 1. Also a factor of x to the 5th plus 1 because there was no remainder. Just like down here, the quotient is also a factor when there is no remainder. So if I multiplied x to the 4th minus x cubed plus x squared minus x plus 1 back with x plus 1, believe it or not, after you do all that multiplication, which would be horrendous to do, you would end up with x to the 5th plus 1. And you can probably kind of see that because look how your quotient signs bounce from positive to negative, positive to negative, positive to negative. You're going to have a lot of those opposite terms coming in and dropping out. So you're going to end up with x to the 5th plus 1. If you multiplied it back out to check it.
Yeah.
Do you see where I got the terms from?
I want to know why you started with 4. Is it because...
Okay, I can explain that. Let me get a different color here. I'll go to a green. I started out with an x to the 5th. I took out a factor of x. So if you divide x to the 5th by x, what are you left with? What is
4.
X to the 5th divided by x is
5.
Careful, there's an understood 1 here. What do you do with those exponents?
It would be x to the 4th.
It would be x to the 4th, and I'll show you why. This is the same thing as x times x times x times x times x over x. Anything divided by itself is 1, and I'm left with x to the 4th. So I started with a 5th degree polynomial, took out a factor of x. The next thing I'm left with is an x to the 4th, x cubed, x.
All right.
And if you were to continue the synthetic division process like you have to when you're graphing these polynomials, you're going to go down in your power of x each time you find a factor.
All right.
You have any questions about that?
No, this is fairly more simpler to me than long division. It just is going to take some repetition to get used to.
Absolutely. Absolutely, and that's exactly why I assign homework, not for y'all. It's absolutely because you just have to practice with this stuff. Just watching it is one thing. And I see it all the time. Students will sit in class, yeah, I understand, yeah. They're not writing anything down, and they're not practicing it themselves, and then they get home and they open up their homework and they're like, I have no idea what I'm doing. So it is practice that is key with mathematics. Feel better about long division and synthetic division?
I definitely do.
Very good.
Thank you.
Well, I'm going to have to close shop here because I've got a face-to-face class in about 20 minutes that I still need to get ready for. But thank you so much for meeting with me this morning, Ren. And, you know, if you encounter any other questions about this, you can just shoot me an email. And if it seems like one of those questions that everyone would benefit from, I'll certainly post it in the news feed.
Yes, I really appreciate your quick responses on the emails and the homework questions and everything. It's much appreciated.
Absolutely. That's my job.
Thank you.
Have a great day, Ren.
You too, Ms. Gore.
Bye-bye.
Bye.